All right, so our notes today are on linear equations once again, but this time it's 2.4b because we're going to write the equation of a parallel or perpendicular line given a slope and a point on the line. So our language objective will be to first define parallel and perpendicular, so that's where we're going to start today. So we have parallel and perpendicular lines, and we'll start with parallel lines. And parallel lines are, the key point is their slopes are equal. So we're going to draw what they look like. So I'm going to sketch a graph right here. Bear with me. X-axis, y-axis. This were one line. The parallel line would be going the same direction at the same rate. So we could call our first equation y equals m1x plus b1, and our second equation y equals m2x plus b2. And our key information here that we need to remember is that m1 is equal to m2. So if they are parallel, their slopes, m1 and m2, are the same, they are equal, but we also must note that b1 cannot equal b2. So if we remember, m in slope-intercept form is our slope, but b is our y-intercept. So if the two lines are parallel, they can't have the same y-intercept. Otherwise, they'd just be the same line. So if they have the same slope and the same y-intercept, it's the same line. So they wouldn't be parallel, they'd be the same line. So if they are parallel, they'll have the same slope but different y-intercepts. Perpendicular lines are the opposite. So perpendicular lines, the slopes are negative reciprocals of one another. So again, if we sketch a graph real quick, we'll do our y-axis, our x-axis. I'll draw one like this. That will be our first line. Our second line would intersect the first one at a 90-degree angle. So this isn't perfect, but bear with me. We'll say that's a 90-degree angle. So those are our perpendicular lines. So we'll again call this y equals m1x plus b1, and this equation would be y equals m2x plus b2. And in this case, our two lines, our slopes are negative reciprocals, so that means m1 times m2 is equal to negative 1. So if you remember our inverse property of multiplication, if you multiply two numbers by each other and you can cancel them out by doing 1 times 1 over itself. Don't worry too much about that. But what this means is we can flip it and negate it. So if we took m1, we flip it and negate it, and we'll get m2. Or similarly, if we take m2 and we flip it and negate it, we'll get m1. So you can just flip and negate and you'll get your new slope when you're working with perpendicular lines. So this is our information for perpendicular lines. We'll practice it in just a second, but make sure you have all this information down before I turn the page. All right, so our example. I want us to write the equation of the line perpendicular to y equals negative 4x plus 2 over 3 that goes through the 0.85. And I want us to write it in slope-intercept form. Okay, so first thing we need to do, step 1, is determine our slope, or determine the perpendicular slope. So my original slope, we'll say m1, is -4. So then M2 is going to be this number flipped and negated. So if I flip it into a fraction, I get 1 over -4, but then I'm negating that, so it becomes positive. So since it started out negative, I flip it into a fraction, so it becomes 1 over 4, and then it was negative, so now it becomes positive. So you flip it and change the sign. So I'll put a little star here, flip, and change the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. Now I'm going to substitute into point slope. So I have my coordinate, I have my slope, so I can plug into point slope form. So I'm going to do y minus my y coordinate is 5 equals 1 over 4, and then x minus 8. So since I'm writing in slope-intercept form, I don't actually need to cancel out my fraction. So if you'd like to, you can add that step. I'm going to skip it, but I can show you in class if you'd like help with that. But my real goal this time, since I want slope-intercept form, is to isolate y. So I'm going to, all I have to do to isolate y in this case is add 5 to both sides. So I get y equals 1/4 x minus 8 plus 5. But then I also want to write in slope-intercept form, so I need to distribute and simplify into slope-intercept form. So I'm going to distribute my 1/4, and I get y equals 1 over 4x minus 1/4 times 8, or -8, is going to be 8 divided by 4, which is 2, or -2, plus 5. And then I'm going to simplify, and I get y equals 1/4 x plus 3. So that is my simplified form, or slope-intercept form of my perpendicular equation to that line. So that's when we're done for that problem. Make sure you write down any questions, comments, concerns you have on it. I'm going to give us a quick check really fast. So I want you to write in slope-intercept form. The equation for the line parallel to y equals 6x minus 2 that goes through 1, -3. So try that on your own. I'm going to go over it, so if you haven't tried it on your own, please pause it and go try it. So the first thing I'm going to do, similar to my last problem, is identify my new slope. So my new slope is going to be parallel, so it's going to be the exact same as my previous slope. So my slope in this one is going to be 6. And now I know my point, so I'm going to plug into point slope form. So I'm going to do y minus -3 equals 6 times x minus 1. So I'm plugging in my x and y values. And now I need to turn it into slope-intercept form. So I'm going to start by rewriting this as y plus 3 equals 6 times x minus 1. I'm going to subtract 3 from both sides. So I have y equals 6, x minus 1 minus 3. Then I'm going to distribute, and I get y equals 6x minus 6 minus 3. And I simplify or combine my like terms, and my answer is going to be y equals 6x minus 9. And that is my answer. So if you want to rewrite the steps, you determine slope. You substitute into point slope. The point slope form. Isolate y. And distribute and simplify into slope-intercept form. So that's all we have for today. Make sure you write down any questions, comments, or concerns you have on this so we can go over it together in class.